Last lesson, caching the heel turned a per-run AI cost into a one-time cost per break. And the cache doubled as a PR signal showing which selectors devs renamed. But here's the catch. Our LLM is blind. We send it a snapshot, it guesses a selector, and we just hope it works. Our running example. One test that logs into a shop, adds the backpack, and checks out. The login button's selector keeps mutating across releases. We heal it, but we can't see if the heal actually clicked anything. Enter MCP, the Model Context Protocol. It's an open standard that exposes tools to an LLM over a structured client-server interface. Instead of mailing the model a text snapshot, MCP lets the model request browser actions, and a client executes those calls against a real browser on its behalf. Now the flow changes. When a break is confirmed, the healing locator routes the call to the LLM. But the LLM talks to a Playwright MCP server. That server drives a real Playwright browser, exposing Click, Navigate, and Snapshot as callable tools. The model doesn't read pixels or raw DOM. Through MCP, it requests an accessibility snapshot, a role and name-based tree of the page that's cheaper to reason over than the full DOM. It scans the roles and lands on the button named Login. Note, this is the MCP server's own snapshot tool, not the same call as Playwright's built-in accessibility snapshot in our earlier code. And here's the real aha. Because the browser is exposed as a callable tool, the model can request a click and then check the result before settling on a selector. Wrong guess? It can see the click didn't land and try again. Same heal as before, but now the model can self-correct, at the cost of extra tool round trips. In our code, the routing change lives behind ask LLM4 locator. Instead of just sending a snapshot and passing a reply, that call now drives an MCP client connected to a Playwright MCP server, which can act on a live browser. Heads up, our existing code uses Playwright's built-in accessibility snapshot, while the MCP server exposes its own snapshot tool as a separate mechanism. The payoff is that the selector it returns can be checked against the real page before we cache it. So the upgrade is structural. We went from one blind guess we had to trust to a model that can test its own fix on the real page before we cache it. That can mean fewer bad heals, but it's a trade-off. Interactive tool calls add round-trip latency and token cost, and the MCP server is one more thing that can crash or drift out of sync with your test's state. 3 takeaways. MCP exposes the browser as standard tools. Route healing through it, and the LLM can probe and verify the fix itself. Then cache that tested selector, so every rename heals once, correctly, and your test code never changes. Thanks for watching. If this made it click, subscribe for more.